Okay, so while you guys are constructing, I'm just talking about properties. So in construction one, students did the construction, compared their drawings to neighbors, and said, yes, they are the same. And now they're doing construction two, and we will check it. So students constructed a triangle where the three sides were 5, 7, and 11. Not quite as easy as construction number one, but upon comparison, said, yes, they were the same. Okay, draw a triangle where two of the angles are 30 and 100, and the angle, the side between the two angles. So draw yourself a 6 centimeter line, measure a 30-degree angle, measure a 100-degree angle, and make a triangle, right? So
How long? 6
that's what it says.
I don't know.
Okay, and again, upon constructing this triangle, we found out that they were the same. Okay, and what you're labeling is the two known angles and the known side, right? So you're going to label, let's just say 6 centimeters and like 30 degrees, and then, 100 degrees, and it's going to look like that, right? So, yes, they are the same. Instruction number 4, draw a right triangle.
Oh, right.
Where one side is 5 centimeters long and the hypotenuse is 9 centimeters long. Okay, and students have constructed a right triangle where one side is 5 and the hypotenuse is 9, and yes, they were the same. Instruction number 5, draw a triangle where the three angles are 35, 15, and 130.
So should we just start by that?
So students have drawn a triangle with the three angles known and compared it with their neighbor's drawing and found they are not the same because they might be different sizes, right? Okay, one last one. Draw two different triangles where two of the sides are 7 centimeters and 10 centimeters, and one of the angles not between the two known sides is 25 degrees. Okay, so in other words, don't draw a 10 and then a 25-degree angle, so don't do this. We're not doing that, right? You want a 10 and you want a 7, and you need the 25-degree angle somewhere else. Okay, so draw a 10, put a 25-degree angle here, draw the 7, and finish off the triangle, right? And you see if you can draw two different ones. Okay. Okay, what did we find? Same?
No. Yeah.
Same?
Yeah, enough, yes.
Enough.
Yes,
Down
they're
to
the same. They're just like all the other ones.
anybody else? Are they the same? So, yeah, enough is not enough. They're not the same. Okay? So, now we move on. Alright, so, now you want to start taking some notes on the next sheet, right? Minimum requirements to show that two triangles are congruent. So first, congruent means they are equal in all measures, right? All the angles are the same and all the sides are the same, right? So they're identical. Two congruent triangles have the same sides and the same angles. Oh, sorry. No, sorry. We want the same shape and the same size. Okay, which really is saying the sides and the angles are the same, right? Same size, but they might be oriented differently, right? So when you compared them, if you kind of took the paper and held them up to the light, you might have to twist one around a little bit, and then it would fit exactly on top, right? So if they were the same, we could take everybody in the classes together, stick them, piece of paper, shine a really bright light through, and line them all up, okay? So they might have a different orientation. Okay, so one might be drawn with the long side across the paper, one might be drawn with the long side running up and down the paper. That's the orientation. So how many angles does a triangle have? 3. And how many sides? So how many things can we measure? 6. Minimum requirement to show that two triangles are congruent is three measurements, right? Three measurements. But they must be particular measures, right? They must be three particular measurements. Okay, so there's three particular measurements. So it's not just any three, right? We found that out when you constructed the triangle that had the three angles, and you say, yeah, they're kind of the same, but they have different sizes, right? I mean, because you didn't tell us what size to make this line, so I drew this one really long, and he drew this one really short, but they came out the same angles, but different sizes. Okay, so next page. Side angle side, SAS. If two triangles have two pairs of corresponding, so it's SAS sides, right? Sides equal in length. And one pair of contained angles. And that's not a pair of contained angles, it's a contained angles. And one, so if two triangles have two, well, I guess a pair of contained, okay. Because there's one in one triangle and one in the other, so that'll work. So if two triangles have two pairs of corresponding sides, say these sides are the same, we got like a 7 and a 10, and the contained angles are the same, then all the other corresponding measures will be congruent and the triangles will be congruent. Okay, so that's called side angle side. Next one, side side side. If two triangles have three pairs of corresponding sides equal in length, then all the other corresponding measures will be congruent. So you did that, right? You drew the three sides, and it was tough because it's not easy to, it's easy with the side angle side. You measure a side, you measure an angle, you measure a side, and then you just fill in the third side. We're done, right? You compare it and you say they're the same. With the three sides, if you got them 5, 7, and 11, and you compare it, you can line them up, right? You might be oriented differently, but they will line up and be the same. And one other triangle congruency. It's called angle side angle, or angle angle side, or side angle angle. If two triangles have two pairs of corresponding, so angle, 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 angle. So if they have two pairs of corresponding angles equal in measure and one pair of corresponding sides equal in length, because really, if we know two angles are the same, what do we know about the third angle? It's the same. Okay? And if the corresponding sides, so this says I have an angle, then the side, then the angle, right? So I know this angle, and I know this angle, and I know the side in between them, then they're congruent. Or if I have two angles and then I know this side, because really, if I have two angles, I really get all three, right? I mean, if I know two of them, I can calculate the third. Or side angle angle. Okay? Generally, we call it angle side angle, right? So if you know two angles, figure out the third and just say, look, I know the angle and this angle, and I know the side in between them. Whoops. Where'd that go? That went back. Okay, and the triangles will be congruent in length. And the last one is called hypotenuse side. If the hypotenuses of two right triangles are equal in length, so if we know the hypotenuses are the same, and one other pair of corresponding, okay, what's it going to be? Because it's HS, sides, are also equal in length, then all the other corresponding measures will be congruent and the triangles will be congruent. And really, hypotenuse side is really just side angle side, right? Because you've got two sides and you've got that 90-degree angle is the same. Or actually, sorry, it'd be more like angle side. But the special one's called hypotenuse side, right? So in right triangles. Okay, what was construction number 1? Was it side, side, side angle, side angle, or hypotenuse side? So look back, construction 1. What were you constructing? Side angle side, right? It said draw this side, then draw this angle, then draw this side. So that was side angle side. And basically what that means is, if those are the instructions, you're to draw this side, then measure this angle, then draw this side, then we all know you're going to end up with the same triangle, right? And that's this whole thing about the triangle congruencies, is we all get the same triangle if we have to do side angle side. What was construction number 2? Side, 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 right? We found the same thing. If I asked you to draw a triangle and it's got 3 sides, and here are the measures, everybody draws the same triangle, right? Might be oriented differently, okay? It might be skewed on, but they are the same size, they have the same angles. And construction number 3 was what? Angle, side, angle, right? To draw this side, have these 2 angles coming off of it. So when you look at the triangle, right, and these are the 3 triangle congruencies, and construction number 4 was what one? HS, hypotenuse side, right? Which is just a special case of one of these guys, right? Because it's got a known angle of 90 degrees. It's not side, side, side. It's 2 sides. So you know 2 sides, and you kind of know the angle between them. Construction number 4 is hypotenuse side. What's the requirement? What requirement is missing for construction 5? What don't we know in number 5? We don't know a side, right? So if we knew a side, so we must have at least one side. We must have at least one side. Okay, and that was the problem when I said draw this triangle with these three angles. It turns out which might be the same size as his. No, just draw whatever you want, right? And then we get different sizes. Those triangles are called similar, right? They're similar. It's like one is a larger version of the other. It's scaled up, or one is scaled down, right? But they're not the same. These guys are exactly the same, right? They will fit one on top of the other. These guys with angle, angle, angle are similar. Okay, they're the same shape, but they have different sizes, or they might have. And construction 6, what were we missing there? Like we had an angle, but it wasn't the special kind of angle, right? So the special kind of angle here, it's the angle contained between the 2 sides, right? So a contained angle. So we need a contained angle. We had 2 sides, but the angle was not contained. Okay, and when we study trig, there's a special, it's called the ambiguous case of the sine law, right? We won't do that in 20-2, but if you go on to do 20-1 or 30-1, it's a thing called, when we do the sine law, I'll talk about it a little bit then. When we do the sine law, if we don't have a contained angle, you can get a couple of different answers. Is that it? No, there's some examples, right? Where are the examples? Examples here? Yeah, it's got to be a worksheet. Okay, so hang on. We'll pause this. We'll find the examples. Okay, a little pause to get things lined up here. So, examples. Prove the following pairs of triangles are congruent. Okay, so remember, here's what we've got. Side, side, side. Side angle, side. Angle, side, angle. And hypotenuse side. Okay? So those are the 4. We can use those. So, number 1, what are we going to probably try and use? Side, 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 side angle, side angle, side angle, or hypotenuse side? Side, 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 right? So the plan, okay, so our plan here, the plan is that we want to use side, side, side. Okay, so we need statements. So we'll say, okay, so A to B, line AB is the same as what? Okay, so line AB is equal to Well, really it's ED, right? Because AB is coming from the 5.7 side to the 4.5. Oh, wait a sec. That's 4.5 and that's 4.4. Uh-oh. All right. Yeah, change it. Change that to 4. I don't know which one's right, but we'll change it. That's 4.5. So AB, so you gotta look, because we gotta take it in the proper order, right? AB is going from the 5.7 to the 4.5. So 5.7, that's ED. So AB is equal to ED, right? And the reason, it's given. It's on the diagram, right? Given. Okay, so AC. What's AC the same as? Okay, yeah, so it goes from the 2.9 to the 4.5, so it's EF. So AC is the same as EF, given. And what's left? Well, we got BC, right? So what's BC the same as? DF. Also given. And then we can now make our statement about the triangles being congruent. So we say, therefore, triangle ABC is congruent to, so there's a symbol, is congruent to, it's an equal sign with a little wavy line over top, right? And that means is congruent to triangle. Okay, name that triangle.
DF.
Okay, so is it DEF? So ABC goes from the 2.9 to the 4.5. Okay, so going from the 2.9 to the 4.5 is EDF. Okay, and the reason is side, side, side. Now, if you want to look at it, when I've named the triangles congruent, right, so if I tell you these two triangles are congruent, it's very important I have the order right. So you can say, look, AB is the same as ED, right? First two letters. AB is the same as ED. AC, the first and the last letters, is the same as EF. And BC and DF are the last two, right? So when you name the triangle congruency, don't just say ABC is the same as DEF, right? That's not really true. Okay? Because what this is telling us also is angle A is the same as angle E. Right? Now angle A is the angle between the 2.9 and 5.7, and so is angle E. Right? Angle B is the same as angle D, and angle C is the same as angle F.
On a test, we have to show like AB equals EB.
You don't have to show it, it's given.
I know, but like
You have to give a reason. This reason is given, right? It's on the diagram. So that diagram says they're both 2.9.
So you don't have to like go through that whole thing.
Yeah, you have to go through that whole thing. You don't have to give the reason why they're equal. The reason why they're equal is because they're labeled as equal. Okay? But you have to say it, right?
Like, yeah, I just so then you have to write that whole
Yeah, see this? It's exactly what you gotta do.
Do you understand?
Okay. Watch that your letters are in the proper order, right? Don't just say, AB is 2.9 and so is DE, right? Yeah, that's true, but AB corresponds to ED. Okay, so you should be able to, when you say this triangle congruency, you should say side AB is the same as ED, angle A is the same as angle E, right? Angle B is the same as, so angle B between the 2.9 and the 4.5 is the same as angle D. It's also between the 2.9 and the 4.5, right? So corresponding sides have to be in the same place, A, B, E, D, corresponding angles in the same place. Okay, here's the next one. We've got a 114-degree angle, a side of 6 and a side of 3. What's the plan? Yeah, side angle side, right? So the plan is to say side angle side. So we need to name a side that's the same. So give me a side.
BCE.
So AB is equal to, so AB goes from the 6 side up, it's the same as FD, okay? Okay, remember, it's got to be in the right order, right? Otherwise, when we go to say this triangle is congruent, we won't have named them properly. Okay, when we say triangles are congruent, That first letter is the angle, in other words, F and A are going to be in the same place, right? Because we know they're both 114 degrees. Okay, what angle is the same? So we're going to say angle.
Angle A and angle F.
Okay, so angle A is equal to angle F. Now let's be a little more specific when we name it. So let's say angle what? You could say angle BAC. So angle BAC is equal to what angle?
DF.
Yeah, angle DFE. So look at it and say, when I'm talking about ABC, I'm going from the 3 side to the 6 side, so I need to go from the 3 side to the 6 side, right? Which is DFE. And somebody else is going to get that and do that same thing, and then it's just kind of. And what other sides are the same? So we got AB, so AC. So AC goes from the 114 degree angle out, and FE goes from the 114 degree angle out. Okay, reasons, these are given, right? They're all given. Therefore, triangle, so I'm going to name it ABC, is congruent to triangle. Now I have to name this properly, so what's the name? FDE, right? So we're going from the 114 angle up the side 3. So we go from the 114 angle up the side 3. So FDE. Okay, and the reason is side angle side. Okay, so that tells me angle A is the same as angle F, which are both 114. Tells me angle B is between the 3 and the side we don't know, is the same as angle D, which is between the 3 and the side we don't know, right? So if I give you a statement that says ABC is congruent to FDE, then you can read it, you can say angle A is angle F, right? Angle B is the same as D. Angle C is the same as E. Side AB is the same as side FD. Side BC is the same as DE, and side AC is the same as FE. Okay, so make sure you can read that out of your triangle congruences. Okay, next one. So, what's the plan? Hypotenuse side, right? So the hypotenuses, right, are opposite the 90, and they're indicated, well, so 1 dash indicates these guys are the same, right? The 90 degree angle is the 90, and then we also have this side, which is the side that's the same, okay? So the plan is HS. So what's the hypotenuse in this guy? XZ. And what is XZ equal to? So is it P to R or R to P? R to P, right? So you look at X. X is coming off of the right angle, right? So I need the side coming off of the right angle, which is R, and then I'm heading down to, the other end of this. So R to P. Okay, so that's the hypotenuse, right? Given. Let's name the sides that are equal. So what do you want to call this side? XY. And what's it equal to? QR or RQ? Really? Because XY goes down to the 90. So RQ. Okay, and that's given. So triangle, okay, if we call it XYZ, what's it equal to? PQR, yeah. Okay, so make sure, if I'm going X to Y to Z, I'm going from here down to the hypotenuse along the side with the 2 and then out. So I need to come down here along the side with the 2 and then out from the hypotenuse, so PQR. Tells me angle Y is the same as angle Q. X is the same as PZ, XY corresponds to, so XY, these corresponds to RQ. Got a little problem there. So is XY the same as RQ, or is it QR? That's a little strange. So XY, double sign. XY corresponds to PQ, not RQ. Okay, so hey, we found a little error in the proof, right? Because we labeled these. XY is going along the side that's 2 down to here, and that's PQ. So XY and PQ are the same, right? We had labeled it as RQ. That was wrong. So XY, and how did I check that, right? By saying XY corresponds to PQ, but I'd written RQ there. So, okay, wait, they're not the same. The side that's 1, right, is XZ, has 1 tick, and then that's the same as PR.
I have a question.
Yeah.
Like, do we always have to, if they write the little box thing in it, even if it isn't actual right angle,
If they write the little box in it, it is a right angle. Okay. You can't write the little box in something. That would be just wrong. Okay? So, no. So a lot of times you'll see triangles that look like right angles, that maybe even are right angles, but if you don't see the box, or it doesn't tell you the lines are perpendicular, or it doesn't say that this angle's 90, you can't assume it.
But then if that's the angle, can you say it's 90 degrees, if it actually is 90 degrees?
If they don't say it, we would have to prove it some other way. Okay?
Okay.
So it might be that the angles are 90, and there are other ways to prove it, right? But we would need to either somehow show, hey, look, these lines are perpendicular, therefore the angles are 90, or what else we do? I got a Pythagorean triple in both of these, therefore the angles are 90.
Do we get our own protractors for the test?
No. Okay, statement. What have we got? Got 2 angles. We got angle H and angle J are the same. We got this angle is the same as this angle. What are we going to do? Well, can we prove this? Yeah, do you see any sides that are marked the same? On your diagram, are any of the sides marked the same? Okay, so we're going to have to add a little something here, right? So let's just say that this side is the same as this side, right? Because what do we say? Without a side, we cannot prove congruent, right? We need a side. And the way it was, we didn't have a side, so I'm giving you some more information. Okay, so what's our plan now? Plan is angle, side, angle, right? Okay, so angle, let's call it, what do you want to do? The one with the 2 or the one with the 1?
One with the 1.
Okay, so name it, what? FGH? Angle FGH is equal to, so where are we going from? So KIJ, right? KIJ. Okay, and that's given. We got 2 sides the same. Name the sides. What's the side here? GH is the same as what?
JI.
Okay, GH goes from the 1 to the 2, so we got to go 1 to 2. We got to go IJ. Okay? I mean, technically, GH is the same as JI, right? They're marked, but if we try and keep the names in the right order, then when we make the statement of the triangle congruency, we won't be looking at things and say, but wait, my letters are out of order here, and then stuff's not really true. Okay, what's the other angle that's the same? So we said FGH.
Oh, JHF.
Yeah, GHF. Angle GHF is equal to what? IJK, right? So we're going from GHF, we're going from the single angle up to the H and out, so we go I to J to K. Reason given. Triangle. Okay, so if we call this FGH, then what do we call this? K-I-J, right? K-I-J. Okay, if we've kept things consistent, then I should be able to say, okay, well, angle FGH would be the same as KIJ, right? FGH, KIJ. GH is the same as IJ, right? In order, GH, IJ. Angle H, so this angle here is the same as angle J, so the third letter here is the same as the third letter here. Okay, and the reason was angle, side, angle. Okay, one more. In triangle ABC and triangle DEF, the following is true. So we're going to have to draw out a couple of triangles, right, which are likely congruent. Right? So why are the two triangles not necessarily congruent? So we're going to give a reason why they aren't congruent.
It doesn't have another side or another angle.
Okay, so ABC and triangle, I'm going to make them look kind of congruent, right? DEF, kind of. Okay, so they kind of look congruent. Angle BAC, angle B, so mark that with just a little angle mark, right? BAC, the same as DEF. Okay, so those angles are the same. AB is equal to DE, so AB, DE. BC and DF. Okay, so what are we looking at here? Side, side, angle. Or, if you want to get yourself in trouble, angle, side, side.
Oh.
Yeah, and so that doesn't work if you have angle, side, side. You will make that of yourself if you try and use that. So why are the two that they might be congruent, but we can't prove it, right? So we have two sides. We have two sides and an angle which is not contained. And wow. Let's undo that. Two sides and an angle which is not contained. So we need a contained angle, which is not contained. Okay. Right? So you have your triangle congruencies, right? Side, 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 angle, side. That's the contained angle, right? Side, then side. Or angle, angle, side, any version of that. Because if you have two angles, you know the third angle, right? So angle, side, angle, 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 side, they all become angle, side, angle at some point because you can calculate the third angle, and we know we got to have at least one side, right? Okay, so there you go. And then you got hypotenuse side, which really if you've got the hypotenuse and the side, then the third side has to be the same by Pythagorean theorem. So you really got like side, angle, side, right? It's a special case of it. We don't even have to mention it, but it just becomes really side, angle, side. Okay.